principles of 2D animation.
Hello and welcome everyone. I'm sitting here to do the demo. My name is Rubaiat Habib. I work in the UI research group in Autodesk Research. And this talk is about how can you make your drawings and doodles expressive, just like the master Disney animators. So this work is done together with my colleagues Tovi Grossman, Nobuyuki Umetani, and Fitzmaurice from Autodesk Research. Now, a couple of years ago, we presented Draco, which is a sketch-based tool that makes animation as easy as sketching. And in this line of research, our goal is to realize dynamic drawings as a new, powerful medium that takes the best of drawing world and animation world, the fluidity of the sketching, and at the same time, the communicative aspects of animation, without all the complexities of timeline. Now, our beta users surprise us by creating wide range of contents, but still, it lacks the expressiveness of cartoon 2D animation. So we wondered, how can we bring this life of exaggerated dynamics of cartoon animation into dynamic drawings? Now, the master animators of Disney developed these 12 principles of animation. So this principle addresses different aspects of 2D animation. Some of them are about the motion design. Some of them are about the quality of sketching, like solid drawing and appeal. Some of them are about clarity and communication, and others are about the process and timing. Now, let's think about this example. How do you create this drawing? Conceptually, forget about the interface for now. Conceptually, how do you create this animation in your mind? At first, you have to add follow-through for the momentum, and then staging for the motion lines, then slow in, slow out for the timing, and then squash and stretch. So this points to an important attribute of these principles, that they're composable nature. That's how we think as human beings, right? We break down complex problems into simple, understandable chunks and then combine them together. So the basic design philosophy of Squid is that complexity arises by composing simple, understandable chunks. These principles also tells us that animation as an art form has its own language and terminologies. So when two animators talk with each other, they often say like, look at the anticipation of the drawing, or like, I wish you had more staging in the character. But this language didn't carry through in the computer interfaces, because most of these interfaces are developed by scientists and engineers, not artists. So we wanted to leverage this traditional language of animation as a way to communicate with computer tools. So I will switch to a demo, and I hope the projector works. So this is the Squid interface. So you see, let's start by sketching a simple box here. Box is not happy with the projector situation. So you see, once you create an object, it shows all the amplifiers on the top of it. So this amplifier corresponds to different principles of animation. So in this case, there are 7 amplifiers, because we do not address the amplifiers related to the drawings or communications. We are mostly addressing the amplifiers related to the motion. So you record a simple motion here, and the object starts moving. So now I want to apply slow and slower. So I tap in one of the slow and slower amplifier, and the object immediately exhibits that behavior. So you can see the motion profile in the bottom. That shows that the velocity is at its high peak when the object is in the middle of its motion path. So you can override the motion path with the sketching. Now let's apply squash and stretch. So I select the squash and stretch, and you can see the object is exhibiting squash and stretch behavior. So for each of these amplifiers, you can say what is the strength of this amplifier. If we want more squash and stretch, we can increase the value or we can decrease the value. Now I want to highlight the motion a little bit. So let's add some staging. And that adds motion line to the thing. How about some drag? So you see now the object is like dragging behind. Now we can also specify what part of the object should drag. So we can say that, this part of the object should be solid, and the remaining part of the object should exhibit drag. Yeah. And then, so you see, Squid exposes these principles in a way that it's very easy to understand them, apply them. And then we can see like how would it look like if we take away the staging, or the drag, or the squash and stretch, or again put them back. So we're done with the box, and now we will bring a fox. So here, in this case, the fox has two body parts, the tail and the main body. So again, we will like simply specify, animate the tail first. So we will specify some solid region, and then record a motion. And we can like increase the velocity. That's too fast. Maybe this is just about 9. Fine. And then for the main body, again, we will specify the main rigid part which will be animated, and also specify the stationary part that is like that will stay fixed, and again record a motion. So you see we can actually change the pivot. Now the object and tail is like animating with asynchronously. They are not related to each other, but we can add some relation using the secondary motion. You see now the tail is moving with respect to the main body, so it adds extra level of expressiveness to the animation. Now, one of the important property of our tool is that it's purely geometric. So it requires no skeleton, unlike many of the 2D animation tools where you have to specify skeleton and topology. It works on purely free-form sketching. So in this case, we specify arc, and then record a motion like this. Apply slow in, slow out. You see, because of the arc, the object is now deforming along the path. But what if we want to add squash and stretch? You see that the object is now stretching along the path. Add some staging. Now there is a motion line. So you see it gives this human interface. So as a human being, we can communicate with this computer using this like natural language. What if we want some anticipation? Now the object goes back before moving forward. But at the same time, it gives us this artistic expressiveness so that we can configure each of these effects. In this case, we can specify that this is the desired anticipation pose, or this is the desired anticipation pose. And this is the resulting animation. Now, let's try something different, the bouncing ball. Now, the classical animation is all about the art of timing and spacing. This is a great example of this. So consider a bouncing ball. When it starts from a normal position, as it goes down, it stretches. So near the impact point, when it hits the ground, it moves from stretch to squash position without moving. And then it goes back from squash to stretch position, and then goes up to normal position. So you see, you need to get the timing and spacing right to get this like collision effect. So now let's try to do this. So record a motion fast. Slow in, slow out, squash and stretch. Now we want the ball to move from stretch to squash position near the impact point, right? So this is the motion profile of the squash and stretch. So in this case, we will configure the stretch. We will move it from stretch to squash position. Okay, so you see ball now like moving from stretch to squash, but it's too fast. So we want to slow it down a little bit. Almost there. And then finally we will add so this is the resulting animation. So see, even though we don't have any timeline, it provides, the motion profile gives you that artistic control to create these kinds of timing and spacing. Okay, so here is a clock on emission without any amplifiers. If we add squash and stretch, this is how it looks like. And if we add dragging and staging, this is how it would look like. So in this case, the order is reversed. If we take away the drag, this is how it would look like. And if we take away the squash and stretch, this is how it would look like. So you see, as an interactive tool, Squid enables you to see what each amplifier adds and takes away from the animation. So from a learning point of view, this is very powerful because it creates the condition for invention rather than providing ready-made knowledge. These are some of the early sketches of the amplifier designs, but for the final design, a lot of inspiration came from the Pixar's inside-out character designs. I mean, I think as a visual designer, we have a lot to learn from character designers. How do they portray these abstract concepts with characters and create these emotional connections with the audiences? So, as you see, in our implementation, we have interface between these amplifiers with a dynamic simulation that is fast, stable, and controllable. How did we do this? So this is the most interesting part of the talk, so pay attention. So this is called the principle of surprise. I mean, to do this, the reason to execute this is to show that what was the challenge associated with this project. Often these animation principles are very broad in concept. So for instance, anticipation, staging, surprise. So the primary problem is characterization. Like if you had an 8th amplifier surprise, how do you characterize it? How do you implement it? In a way that is composable with the others, in a way where you can control it. So that is the primary challenge. So for those who are interested, this is more like an exercise task. So it's like the textbook where the most hardest one is always left for the exercise task. So. And we also invited some user study to try out our system, and these are some of the animations done by the users who have never done these kinds of animations. The users like the way how we interpret these concepts. It makes it easy and accessible to an average user, so you don't need to be an animator to apply these principles. This is another one, and again, you can see the timing, the squash and stretch, and the drag behavior. Our users also felt that this type of tools would improve the quality of 2D animations in TV production and other forms of motion graphics. Now, on a final note, just what is the difference between, we often talk about animation style, animation principles. What is the difference between these two? Where is the line? So all the amplifiers presented in this tool are just a style. This is a Disney style. But there are all these other beautiful animation styles, right? A great, an interesting future work would be like to characterize other types of styles into these animation amplifiers. Imagine having an animation language in terms of these amplifiers where you can mix between these styles or even define your own style. That would be a fascinating language, right? With that, I'd like to thank you for your attention, and I'd also like to thank my co-amplifiers, without whom this work would not be possible. Thank you.
So we have about 5 minutes for questions now.
Hi, Jennifer Jacobs, MIT Media Lab. Thanks for the great presentation and live demo. I guess the last point you touched on is actually the most interesting to me, this idea that animators might want to define their own amplifiers or low-level behaviors. And I'm wondering if you have any thoughts about what that approach might look like. You're defining them right now through a programming language, but ideally you'd have them in some sort of interface that relates to what you currently have. Do you have any thoughts about that?
That's a good question. I mean, honestly, I don't have a great answer for this right now, but we thought about it. But it's not very easy how to define these kinds of your own amplifiers with visually. So the only thing I can say is that with programmable amplifiers, you might have to specify, you have to write your own codes. But I think an interesting avenue would be like, how can you define your amplifiers visually using a visual language? But I don't have a good sense how that can be done. That remains as a future word.